Every building you have ever walked into was built with the same basic recipe. The same formula engineers have been using for over 200 years. The same mixture that has not fundamentally changed since before electricity existed, before cars existed, before anyone had ever heard of carbon emissions. And right now, that recipe is quietly destroying the planet. Here is the number most people never hear. Concrete production is responsible for roughly 8% of all global CO2 emissions every single year. That is more than every airplane flying in every sky combined. It is nearly as much as every car and truck on every road on Earth. And here is the part that should genuinely stop you cold. Even if you powered every cement factory on the planet with perfectly clean energy, you would still release massive amounts of carbon. Because the emissions are not a side effect of dirty power. They are baked into the chemistry of the stone itself. Nobody had cracked this problem in 2 centuries. Thousands of researchers tried. All of them failed at scale. Until someone asked a question so simple it almost sounds stupid. What if you did not change the recipe at all, but added something to it that nobody could even see? What they added was 1 atom thick. And what it did to concrete is something engineers are still struggling to fully explain. But before we get to that, you need to understand why concrete was considered completely untouchable for so long. Because that context is what makes what China just did so significant. Concrete is not just popular. It is the second most consumed substance on Earth. The only thing humans use more of is water. More than oil, more than steel, more than timber. After water, concrete wins by a landslide. And the reason is simple. No other material offers everything concrete offers at the same time. It is cheap enough for developing countries to use at massive scale. Strong enough to hold up skyscrapers. It can be poured into any shape imaginable. It hardens on its own without any special treatment. It does not rust, rot, or shatter. And it lasts for decades with almost no maintenance. For most of human history, nothing came close. The entire construction industry, every crane, every blueprint, every building code in every country on Earth, was built around one assumption. Concrete is the answer. But here is what most people never hear about. The carbon problem in concrete is not a problem you can engineer away. To make cement, the key binding ingredient, you have to heat limestone to over 1,400 degrees Celsius. At that temperature, the rock breaks apart and releases carbon dioxide as a direct chemical byproduct. Not a side effect of burning dirty fuel. The CO2 comes from the stone itself. If concrete were a country, it would be the 3rd largest carbon emitter on Earth, bigger than India, bigger than the European Union. Researchers spent decades trying to crack this. Some replaced part of the cement with industrial waste like fly ash or slag. Others developed entirely new chemical binders. A few experimented with carbon capture at cement plants. All of these helped at the margins. None of them changed the fundamental economics enough to go truly global. And here is the thing nobody wanted to admit out loud. Every approach that tried to fix the carbon problem also made the concrete weaker, more expensive, or harder to work with. The industry kept hitting the same wall. You could have cheap concrete that destroys the planet, or you could have expensive experimental concrete that nobody would actually use at scale. That trade-off stood for 200 years. Then graphene entered the conversation, and everything changed. Here is what most people will never hear about graphene. And this is the detail that changes everything about this story. Graphene is not a new chemical compound. It is not a synthetic polymer created in a laboratory. It is pure carbon. The same carbon that makes up the pencil lead you used in school. The same carbon that is in coal, in diamonds, in every living thing on Earth. What makes graphene extraordinary is not what it is made of. It is the structure. Graphene is a single layer of carbon atoms, arranged in a perfect hexagonal pattern, like an infinite honeycomb, exactly 1 atom thick. That makes it the thinnest material ever discovered by science. If you stacked 3 million graphene sheets on top of each other, the result would be approximately 1 millimeter. You would need a microscope to see it. And yet, despite being 1 atom thick, graphene is 200 times stronger than steel by weight. It conducts heat and electricity better than almost any substance known to science. It is extraordinarily flexible. It does not corrode. It does not degrade. And it is made of the most abundant element in the universe. Scientists first isolated graphene in 2004. The researchers who did it won the Nobel Prize in Physics in 2010. The scientific world immediately recognized that this material was unlike anything ever studied before. The potential applications seemed almost limitless. Electronics, medicine, aerospace, energy storage. But here is where the story gets genuinely interesting. For years after the Nobel Prize, graphene stayed trapped in laboratories. The problem was not the science. The problem was scale. Producing graphene in the tiny quantities needed for research was manageable. Producing it in the quantities needed to mix into millions of tons of concrete, that was a completely different challenge. And for a long time, nobody had a reliable answer. But while Western research institutions were slowly working through the problem, something was happening in China at a completely different speed. China was not just researching graphene concrete in isolated university labs. China was building the infrastructure to produce graphene at industrial scale, and testing it in real construction projects simultaneously. And when you understand China's relationship with concrete, you understand why this matters so much more than any other country doing the same thing. China between 2011 and 2013 used more cement than the United States consumed during the entire 20th century. Not in a generation, not in a decade, in 2 years. Entire cities built from scratch. Highways connecting regions that previously had no roads. Bridges over rivers that had never been crossed. The scale of Chinese concrete consumption is so vast that even a small percentage improvement in efficiency creates an impact that dwarfs what any other country could achieve. So when Chinese research teams at institutions like Zhongyuan University of Technology and universities across Guangxi Province started publishing graphene concrete research, and publishing it openly under licenses that allowed any engineer anywhere to read and replicate it, the global construction industry started paying very close attention, because the numbers coming out of those studies were not incremental improvements. They were not the kind of marginal gains that previous attempts at better concrete had produced. They were numbers that made engineers stop and read the paper again, just to make sure they had not misread something. And here is the part nobody is talking about yet. Those numbers are just the beginning of what this material can do. Let us put the actual science in front of you, because this is where graphene concrete goes from interesting to genuinely shocking. When researchers add graphene to a standard concrete mix, not replacing the recipe, just adding graphene-infused water to the existing ingredients, something happens at a microscopic level that changes the entire internal structure of the material. Think of standard concrete under a powerful microscope. What you see is a mixture of cement particles, aggregate, and water, but also thousands of tiny voids, microscopic gaps between particles, empty spaces where the material did not fully bond. These voids are not a flaw in the manufacturing process. They are an unavoidable feature of how concrete has always worked, and those voids are where every concrete problem begins. Cracks start at voids. Water gets in through voids. Road salt and chemicals travel through voids to reach the steel reinforcement inside, where they cause corrosion that slowly destroys a structure from the inside out. Graphene changes this at the molecular level. The graphene particles, each one just 1 atom thick, work their way into those microscopic spaces and fill them. They create a denser, more tightly bonded internal structure. The result is a material that looks identical to standard concrete from the outside, but is fundamentally different on the inside. Here are the numbers that stunned engineers when they first saw them. Graphene concrete is 2.5 times stronger than standard concrete in compressive strength tests. It is 4 times less water permeable, meaning water and chemicals have dramatically more difficulty penetrating the material. Structural strength increases of over 50% have been recorded in multiple independent studies. And the curing time, the time concrete needs to harden to its full working strength, drops from 28 days to just 7 days. But here is the number that made the entire industry stop cold. You can achieve the same structural performance using 30 to 50% less cement. Let that land for a moment. Half the cement. Same strength. In an industry where cement production causes nearly 8% of all global CO2 emissions, cutting cement use by 30 to 50% per project is not a marginal improvement. According to research data, every 1,500 tons of graphene concrete used removes the equivalent CO2 of taking 100 cars off the road. Across the scale of China's construction industry alone, that number becomes almost impossible to comprehend. And this is the detail most people will never hear. The process does not require new machines, new training, or new workflows. The same workers, the same equipment, the same process of mixing, pouring, and waiting, just a different additive in the water before the mix begins. The barrier to adoption is not technological, it is not operational, it is simply production scale and cost. But here is the question that should be pulling at you right now. If graphene is this powerful, if the numbers are this dramatic, why has nobody used it at full construction scale yet? What is the problem nobody is talking about? The answer is not what most people expect. The challenge was never the science. Graphene's properties were understood within years of its discovery. The challenge was producing enough of it. Graphene at laboratory scale cost thousands of dollars per gram in the years following its discovery. At that price, adding it to concrete was economically absurd. A material that costs more than gold per unit weight is not going into a building that costs $200 per square meter to construct. But production costs for graphene have been collapsing, and China is the primary reason why. China is now the world's largest producer of graphene. Chinese manufacturers have driven down production costs to a fraction of what they were just 10 years ago. And the graphene concrete market, which was valued at $18 million in 2022, is projected to reach $151 million by 2031, according to industry analysts tracking the sector. That is not slow growth. That is a market at the beginning of a steep upward curve. While you are reading these numbers, Chinese research teams are already publishing their next round of studies. The gap between what China knows about graphene concrete and what is being implemented in Western construction projects is growing every single month. Here is what that actually looks like in practice. Real-world trials of graphene concrete have already been completed. Not in controlled laboratory environments, in actual construction projects. In the United Kingdom, a company called Concretine developed a graphene-enhanced concrete admixture and conducted a large-scale concrete pour at a farm in Cheshire, demonstrating that the material works under real industrial conditions. Network Rail, the Environment Agency, and Manchester Airport have all shown active interest in the technology. The first 3D printed structure, using graphene-enhanced concrete, was unveiled in 2022. The material is not theoretical. It is not years away from being viable. It already works. It has already been poured. It has already cured. And it has already performed exactly as the laboratory studies predicted. But here is the part that separates what China is doing from everyone else. And this is the thing that should make you genuinely uncomfortable if you are watching from the West. China does not just consume more concrete than anyone else. China produces the graphene. China is running the research. Chinese universities are publishing openly. And China's construction scale means that every percentage point of improvement in concrete performance translates into more impact than the same improvement would create anywhere else on Earth. The West is watching. Some are copying. A handful of companies in the UK and Europe are moving toward graphene concrete products. But the pace of Western adoption is measured in years. The pace of Chinese research and production scaling is measured in months. And the real question, the one nobody wants to say out loud, is whether the gap is already too wide to close quickly. But before we get to that, there is one more thing about graphene concrete that most people have completely missed. A capability that goes beyond strength and carbon reduction. One that could make graphene concrete not just better than regular concrete, but a fundamentally different category of material entirely. Here is what nobody is talking about yet. Graphene does not just make concrete stronger. Because graphene conducts electricity and heat with extraordinary efficiency, adding it to concrete opens up capabilities that traditional concrete cannot come close to matching. Researchers have already demonstrated graphene concrete composites that can monitor their own structural health in real time. The graphene network inside the concrete acts as a sensor, detecting microscopic stress, measuring load distribution, identifying where a crack is beginning to form before it becomes visible to any human inspector. A bridge that tells you when it needs maintenance. A building that monitors its own structural integrity 24 hours a day without a single piece of external equipment attached to it. Other research teams have demonstrated graphene-enhanced concrete with thermal conductivity high enough to function as a radiant heating system. Floors and walls that heat a building from within. No cables, no pipes, no underfloor heating infrastructure. The concrete itself becomes the heating system. These are not distant future possibilities. These are capabilities that have been demonstrated in laboratory conditions and are moving toward real-world trials. And China, with its combination of graphene production capacity, research output, and construction scale, is the country most positioned to move these capabilities from the laboratory to the building site fastest. Now step back and look at the full picture. The construction industry is responsible for approximately 38% of all energy-related CO2 emissions worldwide, according to global energy data. That is not just from making concrete. It includes building operations. But concrete and cement production sit at the center of that number. The most consumed building material in the world is also one of the most destructive to the atmosphere. Graphene concrete attacks that problem without requiring the industry to change how it works. Same workers, same equipment, same process. The additive goes into the water before the mix begins. The batch goes into the forms. The concrete cures in 7 days instead of 28. And what comes out is a material that is 2.5 times stronger, 4 times more water resistant, and produced using 30 to 50% less cement. The simplicity is the most important thing about this breakthrough. Every previous attempt to fix concrete's carbon problem required either replacing it entirely or making the construction process significantly more complex. Geopolymer concrete required completely different chemistry. Carbon capture at cement plants required enormous capital investment in new industrial infrastructure. Compression casting required new equipment at every concrete plant. Graphene concrete requires none of that. You add it to the water, everything else stays the same. But here is the honest part. And this matters, because your trust is more important than any single impressive number. The challenges are real. Graphene production costs, while falling fast, are still higher than the industry is used to paying for admixtures. Supply chains for graphene at construction scale are still being built. Building codes in most countries were written for standard concrete and need to be updated before graphene concrete can be widely specified by engineers. Every country that wants to adopt this at scale needs its own independent testing, its own regulatory approval process, and its own trained workforce. China can share the research, but the rest of the world has to do the work of adapting it locally. And that process, in countries where building codes change on timescales measured in years or even decades, is not fast. None of those challenges change what the science shows. They simply define the gap between what is technically possible right now and what will actually be happening at global scale 5 years from now. But here is what makes this moment different from every previous time someone claimed concrete was about to change. This time, the claim has numbers, verified numbers, from multiple independent research teams across multiple countries, published openly, available for any engineer anywhere to download and check. The Graphene Flagship, Europe's largest scientific research initiative, has confirmed graphene-enhanced concrete as a priority development area. UK Research and Innovation has funded commercial-scale trials. Chinese universities are publishing new data continuously. The global market projections show a sector moving from niche research application to mainstream commercial product within a decade. And unlike every previous attempt to fix concrete's carbon problem, this one does not ask the industry to sacrifice performance for sustainability. It asks the industry to add one ingredient to the water and get back something stronger, faster, and cleaner than what it was making before. Think about what that means at the scale of China's construction industry. China alone consumes more than half of all cement produced worldwide. If even 20% of China's annual concrete production shifted to graphene-enhanced formulations, with 30% lower cement content, the CO2 reduction would exceed what most European countries produce in a year from all sources combined. The material that could make that happen is 1 atom thick. It has been sitting in the scientific literature since 2004. The Nobel Prize was awarded for it in 2010. The construction industry largely ignored it for years because the production cost was prohibitive. That cost barrier is collapsing. China is producing graphene at industrial scale. Chinese researchers are publishing openly. The rest of the world is starting to pay attention. But China is not waiting for them to catch up. So here is the question worth sitting with after everything you just learned. Graphene concrete cuts CO2 emissions by up to 30% per project. It is 2.5 times stronger. It cures in a quarter of the time. It uses half the cement. And it requires no new equipment, no new training, and no change to how construction workers do their jobs. If all of that is true, and the verified data says it is, then why is the rest of the world still mixing concrete the same way it did in 1824? Drop your honest answer in the comments. If this video changed how you see the buildings around you, hit like and subscribe. Because the material that is quietly changing construction forever is already being poured, and most of the world has no idea it has started.